Hi, everyone. Thank you again for joining us for JNation Online 2020. This is our, I believe, 10th session of the day, so we're getting a little bit tired, but we are really grateful for all the audience that's been here for us since the beginning, and of course, everyone else that joined in the meanwhile. So for this session, I'm going to have two speakers. Going to have Robert and Ray. Hey, Robert. Hey, Ray. How are you guys doing?
Yeah, doing great. How are you?
I'm okay. Thank you so much. I mean, I've been asking all of these to all the speakers, but I mean, it's being really unfortunate that you guys couldn't came to Portugal to the presentation here. But hopefully we can bring you next year if things get better.
Let's hope so.
Yeah,
Yeah.
absolutely.
Well, Ray has been here last year. Actually, no, not 2 years ago. So he
Right.
knows how it goes.
It's awesome.
Yeah. So anyway, Robert and Ray, I've seen this presentation before. I really enjoy it because I'm not going to spoil it, so you're going to see it, but they're going to do a very entertaining session, and they're going to talk about Maven, right? So without any further delay, let me give the word to Robert and Ray. So please feel free to go.
Okay. So yeah, this is gonna be really interesting. Partially because I'm in New York and Robert is in the Netherlands,
Yes.
and we're presenting to Portugal. So we'll see how internet works today. And I'm a developer advocate for Google Cloud Platform, and I like to bring some of our technology to developers all over the world. And you might be asking, well, what does Google Cloud has to do with, all of these dependency problems? Just a very quick overview of why I'm here. Partially it's because we do have many, many client libraries for people to use to access our services. And in the past, some of these client libraries have a lot of dependency conflicts that our users are having hard time to use two different client libraries together. A lot of these things have been solved over the past couple of years, and I've been part of the team solving it. And what I do usually is to just ping Robert online and say, "Hey, Robert, help me out." So today's presentation, most of it is just going to be me asking questions, but we're going to reconstruct all the issues that I have faced in the past and how we documented all the changes. And hopefully today is going to be useful for you as well. You can find me on Twitter at Sanadism. And very lucky that Robert is also here. So happy that he's here because I get to ask him all the questions.
Yes. So my name is Robert Scholte. I became a Java champion last year. Very proud of that. And most people know me as the lead of the Apache Maven project. But I also did some work for the project Jigsaw, so the whole Java modular system stuff. So I provided some specifications, asked for changes, and so on. So, but that now is the project has been completed. So now we're back in business for Maven itself. And of course, it's like Ray already said, it happens sometimes that we're having issues, and then he calls me, and we have this nice puzzle. So this session will be about a couple of puzzles and how to solve them. So let's start.
Yeah. All right. Yeah, and all of these puzzles were real puzzles that I have to figure out as well. And together, I asked Robert to help me out. So we were going to see all the issues that you probably face as well. So let's go ahead and take a look at the first example here. The first example here is a very simple example where I'm using a translation API library from Google Cloud, and I'm simply just translating from one language to another, in this case from Mandarin to English. And I'm using Truth, which is a library that has assertions. Right? It's one of the many libraries that has assertions. So in this case, we're using Truth. Okay. And as you can see, this test is very simple, very small. And same thing with the dependencies. If I go to my pom.xml, I only have two things here. We have the dependency on Truth and a dependency on the translation API itself. And that's it.
Well, that's it. So the first thing that I notice is you're saying that Truth is an assertion framework, right?
Correct.
Correct. So you will only need it during the test.
Yeah. Right? Yeah. In my case, yeah, definitely only the test.
Okay. So why doesn't it have the test scope?
Ooh, well, that's a good question. I definitely forgot to do that. And I think that the scoping is one of the most important thing that everyone has to even, to start thinking about even before running into dependency issue, especially if you are creating libraries. Make sure that you scope everything properly so it doesn't bleed through to the other users of your library as well. So in this case, Robert, do you say that we should put this in test scope then? Let's do that.
Yes.
Yeah. So that truth is only used during test, but not all the other scopes as well. But you can see there are actually many different scopes here. If you don't put anything, what is the default?
Right. The default is compile. And compile means that it will be used during compilation, but it will also be available at runtime.
Yep. And so if a user depends on your library, this will be a transitive dependency as well. So that could be one of the issues. But even before we run into any issues, the first thing to do is to make sure that you don't allow dependencies to become transitive dependencies when they are not necessary for your users, right? That's number one thing to do. Excellent. So, okay. So let's fix the scope thing and let's run this, right? It's only two dependencies. Everything compiles in Java. If it compiles, it runs, right? So let's go ahead and run it. And I'm going to use the run here and just do a simple run. And, ooh, interesting. So of course this doesn't work. And that this is the error that we're seeing, which is the no such method error found. And I think this is where we see a lot of the dependency issues manifesting themselves as symptoms. These are symptoms of something has happened in your dependency tree so that the classes may not exist or that there are some version conflicts. And the errors manifest themselves as no such method error, no such field error, no class def found. We usually ask the people in the room, how many people have seen this before? I think everyone who uses Java may have seen this in one way or another. And they are errors because they are irrecoverable. They're not exceptions. They are actually errors because the JVM, nobody knows what to do in this case anymore. Okay. So how do we actually find out what's wrong here?
So, well, this is a sign that something was using a different version of a class. So what I expect is that some code was compiled against this method, and for some reason now there's a different version of this preconditions class on the class path.
Okay. Yep. And based on this package name, we may need to be able to figure out, well, which artifact does this actually contain this class, right? Because that will help us to narrow down the issue even further. How do I actually do that?
Well, of course, in every IDE, you have the support to discover where it's coming from.
Okay, and here we can see that, okay, so there is, this is actually coming from guava. So if I come to the IDE and see the classes, you can see that this is coming from guava. Guava is very, very well known and adopted in many, many different places. But because of it, dependency conflicts also happen with guava quite frequently. In addition to other issues with the way that guava has dealt with the versioning in the past. We're gonna go through some of that later. Okay, so but we know this is guava, but how do I know why this is happening, right? Why did this actually cause an issue? And for that, I'm gonna go to the terminal. One of the things that I usually do. Oh no, what happened to my IntelliJ?
Oh boy.
Wait a second. This is by the way, this is live, and I think my IntelliJ and my Chrome just fused together into one.
Oh, really?
Yeah, I don't know if you see this, but this is just, I think they literally just fused together. And here's my Chrome. Oh, here we go. So here's my IntelliJ again. Whew, that was scary. This is the first time I've ever seen this. So if I go to my application here, and one of the things I usually do is to see the dependency tree, right? Because I want to see what dependency is actually being included. So I'm going to say Maven dependency tree. And okay, there's actually quite a lot. There's quite a lot of things in here for just two libraries. But I don't see anything out of the ordinary here, right? For example, if I do a grep for guava, because this is what people do, right? I'm looking for guava configs. I only see one. Like there's only one version here.
So what you see right here is the resolved tree, as we call it. So these are all the versions of conflicts are already resolved by Maven. So in this case, what we are looking for are the original versions. So what you can do is add -D verbose, or verbose is true. It's exactly the same.
Okay.
Yeah, and this will give you more information.
Wow, look at that. So this is really interesting because previously everything was really clean. But now we're seeing all of these additional information that Robert was mentioning. So for example, here we have guava, but it was omitted for conflict with 28.0 version. So what that means is that even though it was trying to use guava 19, but it was omitted because there was another version of guava in this tree. If I go back to my presentation here, what happened is that we have now 2 versions of guava. Now, how do I actually figure out who are actually pulling in all of these different versions, right? So previously I did the grep with the guava. And if I do it this way, right, I can see that there are definitely different versions of guava, but this tree looks really weird now. This tree looks like a guava is including guava, which is including more guava, and that's including another guava. That doesn't make any sense.
No, absolutely not. Now, this is, of course, because of the usage of grep.
Okay.
And Maven has an option to give you the proper tree. And you can do that with the -D includes. And then you can specify the group ID and or the artifact ID.
Okay. So if I really want to see guava usages here, like to see who are transitively importing guava here, I'm just going to use include. And the nice thing about include is that it keeps the contextual information on where it actually came from. So in this case, I can clearly see that this guava artifact was included by protobuf, which in turn was included by GAX, and then the translate API, and so on and so forth. So this was very, very clear. So that was one of the best tricks I learned from Robert to troubleshoot one of these issues. And but we can clearly see now we have 2 versions of guava. Actually, there are many different versions of guava. We have 26, 28, and 19. So what happened here is that we need to kind of pick only one to use, right? Because there are multiple versions of guava, and we can only have one. And this is where all the diamond dependency problems actually come into existence. But why can we only choose one?
Right, this has to, for this you need to understand a little bit how the class path works. So the class path works, it's in the end a list of jar files. And when Java is looking for a specific class, it goes from the first jar to the next until it hits the specific class for the first time. So if there are duplicate classes, it will ignore all the other ones. So it will only pick up the first. So in that case, it doesn't make sense to have multiple versions of guava on the class path. So that's the reason why there's only one.
Got it. And so how does Maven pick only one then? Because there are many different ways to kind of figure out, well, which one do we include, and how does Maven actually do this?
Right. So what Maven does, we say that the nearest dependency wins. So if you specify dependency in your POM file, we call it the direct dependency. And let's say that's level 1. But that dependency can also have dependencies, of course, and that's level 2. And you can go quite deep. And Maven will go through the whole tree and will find the nearest dependency, and that version will win.
Right. However, that version may or may not work with all of the other artifacts that's trying to use the same dependency, but with a different version, right? And that's where these conflicts exist. But I think one of the most frequently asked question here is, why doesn't Maven just pick the newest one? Because the newest one is usually the best one, right?
Well,
or maybe not.
It depends. So Maven doesn't really understand Semver, so the versioning system. And so what Semver says is that if you increase the major version number, you are allowed to break the API, right? And that's kind of weird, because what we are saying is that all your code should be backwards compatible. Otherwise, it won't work. So the highest version is not always the best version. It can break backwards compatibility or whatever. So the best way to ensure that you are using a specific version is to define it in your own POM file.
Right. And I think that the other thing for me was that as a library maintainer, it's actually the best practice to truly understand what versions are you truly depending on, and that you're exporting it to the end user. Yes. If Maven was to choose a version for you, then you need to understand all of that logic, and the logic can be even more complicated. To me, I actually like this simple approach, which is the nearest one win, because I can always overwrite the nearest version. I have full control over it. Exactly. I personally like it quite a bit. Yeah. Cool. So, I just revealed the answer. That's what we did in rehearsal. But the question to this is, well, some of these examples that we're going to show, right? There's no compilation issue. There's everything compiles fine. You can do all the stuff here, but it manifests itself during the runtime, right? If you're lucky, you find it during the test. But if you're unlucky, or if you don't write test, then you're going to see this when you run the app. And if you're even more unlucky, you're going to see this in production environments. And the problem here is how do you actually reconcile some of these issues and remedy it so you can reduce many of these risks? So in our particular case, how do we actually reduce our risk here to make sure that we don't run into one of these issues?
Right. Ideally, you want to have all your libraries use exactly the same version of a dependency. In this case, you're only specifying two versions of two dependencies, so that might be doable. But in general, it is very hard to have exactly the same Guava version throughout the whole dependency tree. So this is one approach, and the other one is to say, okay, we are going to look for the highest version, as you were saying, or the latest. And for that, we have a plugin, and it's called the Maven Enforcer plugin. And with the Maven Enforcer plugin, you can enforce really things. So if you are thinking of reasons why the builds should break, you should always have a look at the Maven Enforcer plugin. And it comes with a huge set of predefined rules, but you can also write your own rules. Well, let's start with this one. Okay. So this one is the dependency convergence, and this is the rule that says that every version should be exactly the same for a specific dependency.
Yeah, and the Enforcer plugin is actually really nice. And according to a recent survey by Andre Tomire on Twitter, right, there's very few people who actually knew the existence of the Enforcer plugin, but it can actually do a lot of the static analysis or your dependency analysis before you even need to compile your application, right? So this is really neat. So I just added the Enforcer plugin to enforce dependency convergence. What that means is then all of the versions of all my dependencies and transitive dependencies has to agree. And if I are now to do Maven verify, what this will do is to also run the Enforcer plugin, and it quickly tells me that, wait a second, all of these libraries, all of these artifacts, they have different versions that Maven ultimately would have to resolve. And any one of these things could have caused a dependency conflict during your runtime. Right? So like here, we got API common 1.8.1, and there are other versions in there too. JUnit is there disagreeing, right? And ultimately, or truth is there disagreeing as well. So ultimately, all of these conflicts will cause issues or maybe causing issues. Yeah. And what was the other one that you mentioned? The upper bound, right?
Upper bound.
So requires upper bound. I think that is the way to specify the rule. Yeah. I think.
So this one relies on backwards compatibility.
Right. Yeah. So this one makes sure that you have the newest version of an artifact being used. But in our case, this also didn't work because the newest version actually was also breaking other dependencies too. Right. So I think this goes back to Robert's point where, if you even try to use the newest version of everything, but if the newest version is not backwards compatible, then you're still going to see issues because you really just have to reconcile these library versions yourself in that case. But at least we can catch some of these issues early.
Exactly.
Okay. Yeah, so let's move on to see what else we got. Now that we are running the upper bound or convergence plugin, so Maven is catching all of these issues. But now, how do we resolve these issues? How do we get rid of these duplicate dependencies or the different versions that we have?
So there are actually two solutions. So the first one is by using exclusions. Every dependency has also the option to say exclude my transitive dependencies, or the ones that are being defined by the group ID and artifact. So this is an example, and here you say, okay, I will use truth, but I want to exclude the specific version of Guava that is being used by truth.
Yep. Okay. And we can also do that with other things too. And as you resolve your tree to get rid of this enforcer error, what you're going to find is you're going to add more and more exclusions so that you end up with just one set of dependencies with no duplicates whatsoever. And then you have a very clean tree in that case. So for exclusions, we literally can get rid of some of the transitive dependencies so that Maven only has one to choose. So we're doing the resolution for Maven manually.
So there's one danger here. Suppose that we say, okay, our example one is not going to use translate anymore. So we are going to clean up that dependency. Truth is still needs guava. So that's one of the reasons why I prefer not to use exclusions. But instead, I would use dependency management.
Dependency management, that's interesting. What is that? Because I think that's also another really useful feature that is not widely adopted by all the libraries out there today. So how does that work, and how do we use it in our case here?
So dependency management is, in the end, a lookup table where you can specify some global definitions. So the dependencies that you specify here are not yet used by the project. It's just a lookup table.
Yeah, so one of the common thing mistake was to confuse the dependency management section with the dependencies section, right? They're very different in the two, even though dependency management contains dependencies, but it doesn't actually pull in the artifact into your application if it's only declared here, correct?
Only the ones that are specified as dependency are the ones that end up on the class path.
Right. And so why does this help in terms of our situation to reconcile the versions of, say, guava in this case?
So based on this, what Maven will do is, if it sees a specific dependency, it will also verify if there's some specification in the dependency management as well. And in this case, it will use this, it will pick up this version.
I see. So anywhere in my dependency tree now, in this project, that has the group ID of com.google.guava with the artifact ID of guava, they will all be overwritten with the version of 28.1 in this case. I see. So we can also verify this very quickly. So if I were to go back here and go to example, let's see, who did I change it? 3 with dep management. Oh, sorry, 3.
Example 3.
3b.
Minus dash. All right.
Yeah. And if I see the dependency tree again, and then let's do dverbose, and also let's use a new trick here with the includes, which is, we can include just google.guava, guava. Then what we're going to see is that every single version of guava, even in the transitive tree here, their version O has been managed up. So in this case, even for this library, their transitive dependency now becomes guava 28.1 because we specified it in the dependency management section. And with the dverbose, you can clearly see that this version has been managed up from a previous version as well. Okay, so that's really cool. And you did mention that this is a lookup table. So this actually does not resolve the dependency itself, right? So you can actually put in anything that you want. Is that right?
Anything, yes.
So I can say this is Robert's awesome library, and this will still work.
Yes, Maven will accept it. So there's also there's also a danger in this because the version, you could add snapshots there.
Ooh, so here you can add snapshot, and that is not good for anyone.
No, so you can release this, and Maven will say, okay, this project depends only released versions, but in dependency management it has a snapshot. So
I see.
I would also say never add a snapshot to dependency management.
Never add snapshot to dependency management. That's a very good advice as well. Yeah. So with dependency management, what you can use it for is to be able to manage the versions either for your direct dependency or even your transitive dependency so that their versions can agree. And now Maven would not need to choose any versions whatsoever, and you should be okay even with the enforcer rules. Now you can actually have dependency convergence everywhere. Okay. Now for the upper bound rules though, it's very important to remember what we showed earlier, which is that the newer version may actually break the older version. So in some cases, the upper bound may actually not work. But if it does work, it's when the higher version are backwards compatible. And for that reason, we actually have documented a number of rules that's really, or best practices rules, that's really important for client library developers. So this is called the GLBP, the Google Best Practices for Java Libraries. And there are many, many rules here. And these are all of our learnings through resolving many of these issues that we have had in the past. And so two rules here is GLBP 7 and 10, which is saying that make the breaking transition easy. So always make your API backwards compatible for as long as you can. But also GLBP 10, which is to maintain that API stability for as long as possible as well. This way, people can upgrade to the newer version of library without fearing it to be broken. And for that reason, Guava 21 and up, they are all backwards compatible now. Guava has been following Semver for a long time, but however, it's like Guava 10, 11, 12, where they're always breaking backwards compatibility. That's why the version keeps on incrementing, right? But starting from Guava 21, now we have backwards compatibility because of our work that we've been documenting in these best practices. Okay, cool. Now, if the upper version does break the lower version, right? So for example, Guava again is used everywhere. I know that Hadoop uses Guava a lot, and Hadoop uses a very, very old version of Guava. And sometimes our users bring a newer version of Guava, then they cannot work together. What do I do in that case?
So in this case, the Guava version is picked up from Hadoop instead of your own library or your project.
Mm-hmm.
Wow. Well,
yeah. That's hard. That's what happens
very
every
hard.
day.
Yes. So
yeah.
If you're not in control, then the last solution you can do is using the Maven Shape plugin in combination with Relocation. So this is actually a very interesting trick. What you can do is you can say, okay, I want to specify a pattern. Let's say the guava package, and you are going to relocate it to a different package, for instance, or .shaded.guava or whatever. And what this will do is, after compilation, it will go through the bytecode and it will replace all the references to Guava with this new shaded package name. And because of that, there will be no collision anymore with your code and Guava and the Guava that's being used by Hadoop.
Right. Yeah. And this is by far one of the most effective way to really just avoid all of those conflicting libraries, especially in Hadoop. However, also this might embed some of the libraries directly into your application as well, which will potentially increase the size of your app, but also potentially that if you need to upgrade any of these dependencies, you also have to reshade. So you have to keep your application up to date and rebuilding it to make sure that they are shading the newest version of these libraries. But
so it's not
overall, I think it's a really good solution.
Yes. So it's not that easy as just saying a newer version of dependency in your POM file. You have to do a little bit more.
Right. What about class loaders? Because that's another trick that a lot of people use, right? Because ultimately, what happens is that in the class path or in the single class loader, there are duplicate classes where one of them is being picked up or the wrong version is being picked up. What if I do need to have different versions of something?
Well, it all depends a bit on the kind of application you're working on. So let's take Maven, for example. It has a huge number of plugins. Everybody can write its own plugins, and it works pretty well together. And not everybody is using exactly the same version for commons lang or whatever. And that's because Maven uses class loaders. Every plugin has its own class loader, and because of that, all their classes are isolated from the other plugins and from Maven itself. And based on that, it's very cool to isolate all your classes and to not have these class collisions.
Right. But I think what you mentioned earlier was really important, which is it depends on your application as well, right? Absolutely. So if you're writing a library, a class loader may not make any sense because you don't want to class load your own library differently. However, if you're writing a server or a some system with a plugin, right? Imagine like Jetty or Tomcat that may actually run multiple war files or year files, but you may deploy multiple applications into the same application server in the same JVM, but they are able to load these classes differently because of the different class loaders that they have, right? So be careful with that one as well. Okay. Cool. Now OSGI, the last one I want to mention, that's really just an extension on how to make the class loading easier. But to be honest, I don't really know who uses OSGI anymore. So apparently it's a good solution, but I just haven't seen this being adopted a lot. Okay. Cool. So let's see what's next. The other best practice here is that GA libraries should not depend on non-GA APIs. So in some of our libraries, we do specify like unstable API or beta API or internal API. Just don't use those because they are meant to change very frequently as well. And also that when you do upgrade the versions, especially if you have breaking changes, what you also want to make sure is that you may want to relocate the package name or the artifact ID as well. Now, for this one, this is really interesting. Robert, if you're still there.
Mm-hmm.
Yeah, good.
Yes.
Yeah, I think you mentioned quite a few examples for this practice as well, right?
Exactly. So here, what you see is commons lang is my favorite example. So for commons lang 2 and 3, they had to change some new things because, for instance, they were using Java 7, and it comes with new features in the language. And what they did is they introduced a new artifact ID, but they also introduced a new package. And because of that, it is possible to have commons lang 1, commons lang 2, and commons lang 3 living next to each other, because there's no collision because of their unique package names.
Yep. And I maintain a library called JDeferred, and I was being advised to do exactly the same thing. And so for this library, we have version 1, which is under JDeferred, and version 2, which is under JDeferred 2. And people can also use both of the version at the same time as well. So that's really useful.
Yes, it really depends on what kind of application you're working on. So if you're working on libraries that are very, very popular, this is a good practice. If you're working on an application, which is in the end not a dependency for something else, there's no need to change your package or your artifact.
Right. Yeah. So let's see the next example, 3E. This is exciting because we're moving on to the next question for Robert. Robert is like a detective trying to figure out what's wrong with the Maven resolution for me. So let's see what happens here. So I'm going to show another example here, which really just sends up a pub/sub message. So pub/subs are message publish and subscribe service, and this only publishes one message out. Again, this is one of the older APIs and older issues that we had to resolve. And in my pom.xml, we can see that I'm having the dependency here. I'm also pulling Firebase, again, the older version of that. And I'm following the best practices here, right? So I have my enforcer rule. I'm requiring upper bounds. I want to use the newest version of everything. And then we have the dependency management section here to help us to see what's, to help us resolve all the versions to the right versions. So now let's go ahead and try this out. So I'm going to go to example 3E. And the name kind of give away the little hint here, right? So if I do Maven verify again, so we're going to see there's no enforcer issue, but we got yet another issue here. What is going on? And look at that, it's guava again. I thought I resolved this previously.
That's interesting, right? And so this probably means that we're again using a different version from the class file, a different one than expected.
Yeah, but I have my upper bound. I got my guava managed, right? Just like what we talked about earlier in this case. Okay. And we can even go and see the dependency tree as well. So let me go ahead and do guava here, guava. So I'm going to say a Maven dependency tree verbose includes guava, right? Exactly what we did before. And we should be able to see that all of the versions actually agree, right? 28.1, 28.1, right? All of them are being overwritten. So I don't see anything else wrong here.
Okay. Could it be that the class is duplicated? somehow.
You mean in another artifact?
Yeah, in another jar.
In another jar. So so if there's another jar, another Maven artifact that has exactly the same classes that happens to coexist with the one I already have, then again, because they fold into the same class path, only one of them will be picked up, and it could be the wrong version. Okay, so that's interesting. How do we actually find this out? So we kind of know this is guava. So I think the trick here is just to remove the artifact ID, and let's just use the group ID instead. Yeah, let's see what happens. And let's see here. Again, but then you can see like this dependency tree is very long. One of the best practice, of course, is for library maintainers to reduce this as much as possible, because this really becomes really hard to see what's going on. Do you see anything that jumps out at you, Robert?
Not yet. Can you
Not
do
yet?
my,
Are you still reading every line? All right, you go from the bottom, I go from the top.
Oh, yes. Maybe we should, I think you did the verbose as well, right?
I did, yeah.
Yeah, so maybe we should remove that one. Oh, you already found it.
Yeah, yeah. So in that case, let's remove verbose and see if it's easier to read as well, because that might actually be better in this case. Because now we can actually see very clearly. There's actually a guava here, but there's a guava JTK5. What happened here?
Well, I think in the past, people were making different versions of a specific jar file, and they were using different artifact IDs.
Right.
So at that time, it looked like it made sense, but right now we're just having issues with it.
Yeah, because when they are the same artifact ID, then Maven knows that they are the same thing, and so they will try to resolve and pick only one version, right? However, if there are different artifact ID, in this case, guava and guava JDK5, Maven does not know that they are exactly the same thing, and so they'll put both of them onto the class path.
Right.
Yep. And we know it wouldn't work, so that's not good either. So and this again will only happen during the runtime, and we need to resolve it during the compilation time. And Robert, any recommendations on what to do to make this simple when we are building the application?
Right. So it looks like we solved it within a minute, but it took us a little bit more time. But what you can do is you can have this enforcer rule, because again, what we want to enforce is we don't want to have duplicate classes. And this one, as you might see, it is not maintained by the Apache Maven project. This one is maintained by Mojo House. It used to be Code House Mojo, but this also shows you that it is possible to write your own enforcer rules, and you can add this to your project. So what happened is here you see the dependency, and this dependency contains the extra rules you want to add to your enforcer plugin.
Yep. So let me add it to the application too, right? Because this one definitely we found it early, fast during the talk, because we knew exactly what was happening. But in real life, this one took a while to kind of figure out, because the dependency tree was so deep in our real cases. So let's go ahead and add this plugin here and see what you actually get out of it. So here we added the new plugin, and let me do a Maven verify again. The key here is to always try to avoid the dependency conflicts during the runtime. You want to detect it up and front and early during the build time. So with this plugin, we can see all of these classes are being duplicated. All of them. All of them. Oh, well, it's still going. Wait, hold up. How much more time do we have?
Almost.
Wait.
Oh.
There we go.
There we are.
This is the thing I'm interested in,
yes.
Which is the two jar files or the two artifacts that actually causes the issue.
And
right.
in this case, we're lucky that they're in the same group ID. But it can happen that if you use the Maven Shape plugin without any configuration, it will create a fat jar, including all the dependencies. And if guava would be one of those dependencies, it would be in that jar as well.
Right. Yeah, I actually have seen this happening in one of our other SDKs where they did shade, but they didn't do relocation. So there is actually potentially issue with some of the API that's being shaded that since has newer version, and it becomes really hard to reconcile at that time. So yeah, and for that reason, we also have a rule for this also, which is that two artifacts do not have overlapping classes. This is so important, and this is a GLBP rule number 5 that you should avoid. But I know, Robert, you mentioned something else that was really important too, especially with the module system.
Right. So with Java 9, we have the Java Platform Modular System, and it introduces the module path next to the class path. And the module path is the same as the class path, but it comes with extra rules. And one of those rules is that packages should be unique per jar. So you cannot have the same package in different jars. And this is what we called the split package. And this is one of the main reasons why a lot of people, a lot of Java projects are struggling to switch to the modular system. But the cool thing is that your code won't even compile if you have a split package issue. So the things we were seeing right now, it won't happen with the modular system.
Right. So just having Guava and Guava GTK5, like that would have never happened in the module system in the first place. Yeah, that's good. Yeah. So maybe that's a good reason to adopt the module system. I just haven't seen this used. Yeah. And also that Guava GTK5 is from very old version of Guava. And so some of the libraries didn't keep their dependencies up to date. If they did, they will find that GTK5 variation is gone, in which case it would have used the right version. So we also have a rule here to say keep your dependency up to date. Now everyone's using GitHub. I think that there are really, really good automated ways and bots that can actually keep your dependencies up to date. I use one myself, and that's been really helpful for me too.
Yeah.
Okay. Let's see example 3C. What is 3C here? Ooh, this one's fun. This one's really fun. Again, the thing kind of give away, but well, you're going to see why this is the case. So this is yet another publish subscribe client with a different version. You can see the API actually has changed a little bit. But then if I go to the POM, let's see here if I can compile this real quick. See the example 3C. Yeah, and let's do a Maven verify again. Again, I have the best practices here. We got the enforcer plugins, we got dependency management section, and the enforcer rule just caught something for me. So this is the require upper bound enforcer rule, and told me that, hey, look, you got two versions of gRPC stub, and the older version is being used. So you should probably use the newer version here, which is 1.10.1. So now I go back and think about how do I actually do it. We can use exclusions or we can use dependency management. So I'm going to use dependency management to bring up the version to 1.10.1. Okay. So now the enforcer rule should pass. I know I'm using the newer version of something. But if I run the test again, Robert, it's happened again. What is going on here? I'm following everything that you said so far, but this is still happening.
Well, so it's quite clear, right? So the class is missing. So,
yeah, but why?
Why?
And also, it's actually not Guava for the first time, so that's good.
No. So what you could do is you could try to figure out in which version you would expect this class file. So there is this feature in Maven Central you might not know, but you can look up the jars that contain a specific class.
Okay, so I can go to Maven Central.
Right.
And if I just search for Guava or gRPC, I usually just get the artifacts.
Exactly. But you
what is the new trick?
You won't see the classes. So if you you saw the advanced options probably below there, and it gives you a little bit of things you can add to your search thing. And this is the one we're looking for, a full class name.
Okay.
Right. So if we do FC followed by the method, now we get a list of all the jar files that contain a specific class.
Oh, that is interesting. And over here on the top, it looks like some artifact that's being published actually contain exactly the same class. And if these two things were to be together, then you're definitely going to get a dependency conflict as well. And I think this is what happens when potentially when shit is happening, but without the actual relocation.
Right.
Yeah. Okay, so I got all the gRPC stuff here, and you know, I can see all the versions. I don't really see anything different here.
Okay. Well, let's go back to the dependency tree.
Okay. So dependency tree. And the verbose or no verbose in this case?
No verbose, but I think we can reduce it to the group ID for io.grpc.
Okay. There we go. All right. So what's happening here? Oh, look at that.
This is interesting.
So we did have a conflict here with stub, right? And so we upgraded it to the newest version. However, everything else is still using the older version, which is 1.0.1. And from my understanding of this situation, and by the way, this took a long time to troubleshoot as well. Anytime these things happen, it takes a long time to go through the dependency tree to figure out what's going on. And in this particular reason, the gRPC libraries, like all of these different modules, they're actually tightly coupled together. What that means is that you cannot use different versions of these modules. They all have to agree. And this is what we call the problem of version misalignment. That's why this example is called misalignment. What we need to do is to align all of these versions, right?
Right.
So what are the options to align them? Because we learn about exclusions, we learn about dependency management. One of the options is that I can dependency manage every single one of these libraries and update their version to 1.10 individually in my own POM.
Right. So again, you want something to enforce, right? Actually.
Yeah, we want something that will enforce all the versions for all of these libraries.
Exactly. So you might wonder if there is a Maven enforcer rule for it.
Is there one?
Yes, there is one.
What? Really? Which one? This is new. I did not know about this one before.
No. It's called same versions, and that's where you can specify that specific dependency with the same group ID have to be exactly the same version.
Oh, interesting. Now, we did not talk about this in the past, but this is definitely new for me too, and this is great. Look at that.
Yes. However, this is just giving you a warning that your versions are not in sync with each other. So this is actually a little bit too late. This is not the real solution, right?
I see. Yeah, but it is still good to catch this, right?
Oh,
it's always good to see the warning up front. Yep.
Yes. So what we can do is we can make use of a BOM file. And a BOM file is it's called a bill of material. And I think it's introduced like 10 years ago already. But right now we're working on it to make it more public to everybody, that they should use it. So in the BOM file, it is actually, if we are going to open one, you will see that it is a long list of all the dependencies that should be aligned with each other.
Okay, so here's the gRPC BOM.
Exactly.
Yeah.
And here you see dependency management, not dependencies, but dependency management. And here you see all the dependencies, and they are all having exactly the same version.
So this is like having a dependency management section in my own file, except that this is a different artifact here, which I can basically import somehow.
Right. So what you could do is you could copy paste this whole block inside your own POM file, but that's of course kind of ugly.
Right.
So there's what you can do is you can copy this. So just the group ID, artifact ID, version, and the type, which needs to be POM.
Okay.
And you also have to specify the scope.
The
scope has to be import.
I see.
From import.
If you don't have the import, then it will import the dependencies instead, right? And this is why you need the import scope. So it reads the dependency management section for you. Yeah.
Without the import scope, it will look for dependencies. And with import scope, it looks for dependency management.
So now I'm importing the BOM that actually has the versions all aligned for all of their modules. And now if I run this tree again, I can see that through the dependency management section in the BOM, we overrode all of the gRPC library versions, and they are all aligning at the same time now. So that is the easy way to do this, in addition to the enforcer rule, right?
Right.
That's cool. So just to recap, what happened there is that these gRPC versions, they are tightly coupled. They actually need to use the same versions, but they are not, and that's where this internal API actually broke. by using the BOM, we can override all of these versions and translated versions in one shot. And this is why, again, we have this rule now for GLBP, or one of the best practices is that if you are creating a multi-module project, please produce a BOM, because it will make the user's life a lot easier when they are trying to consume your library. However, the BOM can override any dependencies in this case. So, I think that it's best to say that only include the modules within your multi-module project in the BOM. But if I have, say, guava that I'm using as a translated dependency, should I include that in the BOM so that you can make it work when you're using the library?
No, you will make it a lot harder for people to change the version of guava in general, because the order suddenly matters. So no, you should only specify the modules that are part of the multi-module project.
Right. Yeah. So if you're producing a BOM for your multi-module library, do not include your dependencies, but only have your multi-module projects. That's the easiest way. Cool. Now, gRPC also use another method, which is by using a version range, but it's using strict over version range. What that means is that if the version happens to be misaligned, the strict version range will kick in, and Maven will tell you that the versions are misaligned and you need to use a different version. But version ranges should not be used in general, right?
No.
Other than this case. Yeah.
Hey, Robert and Ray.
Yep.
We need to start thinking of wrapping up because we're running out of time.
Yep. Yeah, it's the last slide here. The final thing that if all things fails, then you can use something called the linkage checker. This again is an enforcer rule that will be able to do static analysis on your application and will actually traverse all the codes and make sure that every single code is reachable. And this again is an enforcer rule, and you can apply this to your project. This is an open source project created by Google Cloud Platform, by the team who are dealing with all of these issues as well. So with all that said, I'm going to skip all the bonus here and just say, here's a list of things that you should be looking for. Enforcer rules, there are quite a few that you can use. And you need to manage your translated dependencies as well by using the BOM, the exclusions, dependency management, and stuff like that. With that, I'm going to stop for now and say the reason why I love to do Maven Talk with Robert is because one thing that I learned is that Maven only has a handful of committers, right? But it's used by just about everyone.
Exactly.
Yeah.
So we're having like 5 to 10 active volunteers. So there's no company behind Maven. So we're always looking for contributions and maybe even new committers if we recognize them as understanding how Maven works. So here's a link to go to some open issues, and these should be the easy to pick up issues.
Yeah, definitely. I think it's very important for the community to participate and contribute wherever they can, and help to improve the project as well. Like Robert is one of the few people that I know that works on Maven. I probably know a small handful of them, but that's really it. But I know everybody uses Maven in the Java ecosystem, so please contribute. And last note is that you can find all the rules or the best practices online, which is at glbp.dev. Please give it a try and understand it, and reach out to us if you have any questions. Okay.
Wonderful. Cool. Yeah, wonderful. I mean, awesome presentation as always, Robert and Ray. Yes, so thank you very much for being here with us today. And we do have a couple of questions from the audience, but unfortunately we run out of time. So I ask the audience to reach out for Robert and Ray on Twitter, or even I know that Ray and Robert are on the Slack, so they can answer them over there.
Yes.
So that will be fine. So thank you so much for joining, and hopefully we will be able to have you here in Portugal next year.
Oh, that would be great. Thank you.
Yeah.
Looking forward to it.
Okay.
Okay.
I'll let you go now, guys. Bye-bye.
All right. Thank you. Bye.